In this section, we are going to present you with information about how to make a measurement and determine the reliability of that measurement in terms of possible sources of error. Whenever you make a measurement, there will be a certain amount of error associated with that measurement. We have to evaluate that error based upon how the measurement was made and what the measuring device was. And so we have to evaluate the number of, or the digits that are being read from the measuring device. These are referred to as significant digits. So the significant digits are different than for each measurement that you will make, and in some cases you will also be using what are referred to as exact numbers. Exact numbers have an infinite number of significant digits and should not be things that will limit the range of error in any kind of calculation. So examples of exact numbers are numbers that you get from counting. If you count the number of students in the classroom, there'll be exactly a whole number of students. Likewise, certain numbers are defined, and these will be exact numbers with an infinite number of sig figs. For example, 1 inch is always exactly 2.54 centimeters, so you can imply that there's an infinite number of digits after the 4. Formal fractions, say the volume equation is 4/3 pi r cubed. The 4/3 is got an infinite number of sig figs. Likewise, the value of pi would have an infinite number of sig figs. The r may be something you measure, and therefore would have a limited number of significant digits. As an example of two terms that you should be familiar with, the term precision and the second term accuracy should be understood. Precision is a measure of the reproducibility of a measurement, whereas accuracy is how close does the average of a set of measurements come to an accepted value. A commonly used example of this is shown here, where 3 darts have been thrown at a target. In the first example here, all 3 darts come very close to the center of the bullseye. The average of all of those 3 darts is very close to the desired value, so hence this is very accurate. In addition, the spread is very narrow, so this is also a quite precise person who is throwing the darts. This is a result of lots of practice, and there is not a lot of variation in how the mechanics are being generated to throw those darts. In the second example, now all of the darts are very close to one another, but the average is not in the center of the target. So hence, this person still throws very consistently, but for some reason is not hitting the target. Perhaps there's some mechanical reason for this, and this would be what is sometimes referred to as a systematic error. So this is a very precise result, but poor accuracy. And in the final example, we have a person throwing the darts where the darts are spread out. The average of all of those darts is not necessarily in the middle of the target, so it's poor accuracy. And since the spread is quite large, it's also not very precise. So this is due to the randomness associated with the mechanics of whatever the throwing motion is. Okay, we would also like to be able to determine the number of significant digits that you can obtain by making the measurement using a measuring device such as a ruler or a scale. The significant digits are numbers that you can have varying degrees of certainty about. And then in some cases, numbers will be uncertain and have no meaning at all. The significant digits depend upon the measuring device. So if, for example, we wish to know the length of this particular rod, I would use a ruler. The ruler, it will have markings on it, and in this case, the lines that are marked with 1, 2, 3, and 4 are centimeters, as indicated by the cm on the ruler. There are additional marks that are not labeled. Those are the tenths of centimeters, and we can see that the rod is at least 2.5 centimeters, but not quite 2.6 centimeters. So, in this particular case, to get as much information out of the measurement as possible, we would estimate a digit in the hundredths of centimeters digit. So in this particular case, I see that it's a little bit further than halfway, but not quite the 2.6. So I would estimate that it's 2.5 something. And in this case, if a good estimate would be 2.58 centimeters. If I had guessed that it was 2.59 centimeters, that would probably be acceptable as well, possibly even estimating 2.57 centimeters. It's always implied that that final digit could be one number higher or possibly one number lower than what the guess was. And this is the range of error associated with this measurement. We typically put an underline under that estimated digit so that we can recognize that that's the one that's been guessed at. And so in this particular case, the 2 and the 5 are well known, definitely significant digits, and then the 8 is also a significant digit. So there's a total of 3 of these digits that are significant. We also include the unit so that we know exactly what we have been measuring, and then the final answer is presented as 2.58 centimeters.